Welcome back, everyone, to another episode of Simply Science with me, Miss Rachel. Today we are talking about short circuits. What is a short circuit? Why are they dangerous? The first thing I want you to do, as always, is hypothesize. So on your sheet, hypothesize. And that hypothesis always starts with, I think, right? So start with, I think that a short circuit is, and they are dangerous because, what is a short circuit? What does it even mean? Have you heard it in a movie before? Someone short-circuiting, their wire board is short-circuiting. Try and think about what you might think that means. Okay, now that you've hypothesized, let's look at our materials. So on your materials list, you will need steel wool, a 9-volt battery. Remember, there's a big difference between a 9-volt battery and the regular batteries we use, which are 1.5 volts. And remember, 9 volts is a lot stronger, which means it's not as safe to experiment with. So when you're doing electricity experiments at home or at school, you're gonna wanna work with a 1.5 volts or two 1.5 volts. And you're gonna need a water bucket, but you don't need a bucket, just a small container where you can put out any subsequent fire that you might be seeing and sparks. So as I conduct the experiment, I would like you to make observations of what's happening. Remember, the best observations you can do are the juiciest detail. Pretend you're doing an observation and you're writing an observation as if you were trying to explain it to someone who couldn't see anything. So this is for someone who cannot see in detail what's happening. Okay, slight reposition. So all you're going to do now is take the steel wool, take your 9-volt battery, and you're just gonna rub the positive and negative terminals, which you know is the end of the battery, against the steel wool, and we're gonna observe what happens. So, rub, rub, rub. Do you guys see what's happening? Now, if it sparks a little too much, which I thought it did, and it was gonna get my precious fingers, I'm going to drop it in the water. So, what did you see? Observe. When Miss Rachel touched the 9-volt battery to the steel wool, what happened? All right, you made some observations. Let's do one more round just for fun. So I've got another teeny weeny piece of steel wool. Show it nice up to the camera. It's basically just tiny little wires, almost really fine wires. Okay, I'm gonna bring it over to my water bucket. I'm gonna take my 9-volt battery and I'm just going to touch, just barely touch. And look at that. Whoops. So don't light your steel wool over your computer. That's a lesson that we've all learned here today. Be careful with your steel wool, especially when it's on fire, and try not to show the camera. So let's move on to why did this happen. Batteries have lots of stored up electricity in them, right? We already know that. We know what's inside a battery. There's tons of electricity in here waiting to be used. So when we put our battery into, say, a device, the electricity goes out one prong or a terminal, goes into the device, powers the device, comes back in to the battery, completes the circuit, the electricity gets used up, and it does exactly what its purpose is. So a short circuit is basically a circuit that doesn't have any kind of load or resistor. There's nothing using the electricity. So when I put this steel wool to this battery, there's no light bulb taking up the electricity, there's no motor, there's no blender, there's nothing actually connected to this battery. It's just electricity going in, faster and faster and faster and faster, and going back out. Now we know when things go faster and faster and faster and faster, that creates friction and that starts to heat up. So all that's happening here is we're creating a really short circuit because we're just instantly connecting both terminals, and the electricity is going faster and faster, and nothing is using that electricity. So a short circuit is really dangerous because if there's nothing to use up all this electricity, it's just going to get faster and faster and hotter until sometimes a fire can happen, an explosion, sparks, and that could cause some really bad damage in anyone's house. So with a short circuit, basically, steel wool is like my shortcut to demonstrate to you guys. But if I had a wire and I connected again to the negative terminal and to the positive terminal, if I connected those, the electricity is just going round and around and around and around and around and around and around in that wire until it gets hotter and hotter. This wire could get hot. It could even melt if it gets hot enough, depending on how long it's been there. So I don't even want to connect it right now because that's dangerous. That's very dangerous, so I don't want to do that. So basically, a short circuit is just a circuit, a loop that doesn't have anything using up the electricity. And we really want to avoid ever making a short circuit. Obviously, I made one here today for demonstrations, but that's only to show you guys how dangerous they are. So whenever you make a circuit in your own house, in class, in your own life, you're gonna wanna make sure that it has a load, it has a light bulb, it has a motor, it has something to use up that electricity. Okay, so that is what a short circuit is and why they are dangerous. So let's go to the back of the sheet that you guys have, and there are some questions. So first question, I'll talk through it with you. Maybe you can write as I'm speaking, or you can watch this video, take in the information and watch it again later on when you're ready to answer your question. So what is a current? A current is basically the flow of electricity. Current is the movement of electricity through the circuit. That's what a current is. All right, next question. So we have a regular 1.5 volt battery. We use these all the time in all the devices we have at home that are battery powered usually, or something very similar to this. This is a 9 volt battery. This is quite a bit stronger, 1.5, 9. A household outlet, so our plugs in the walls basically, we call them outlets, can range anywhere from 120 volts to 220 volts. So why do you think that even this little short circuit is dangerous? Why is it so much more dangerous in, say, a house with bad wiring inside of an outlet? Why is that more dangerous than what we've just done here? All right, question C. So in a battery, and it doesn't matter if it's this battery, or it's this battery, or it's a giant car battery, it doesn't matter. What way does electricity flow? Now, electricity always flows from negative to positive. Now, if you look on the picture on your sheet, you can see it's clearly labeled negative to positive. Electricity always flows negative to positive, no exceptions. That's the way it is. So if you can, on your diagram, try and draw an arrow that goes from negative to positive, you are set. All right, let's summarize today's lesson. So what have we learned? 1, we have learned that short circuits are dangerous. They are very, very, very dangerous. We've also learned that short circuits are just circuits without a load, without a resistor, without something to eat up all the electricity that we have saved in these friendly little batteries or in an outlet of a wall at our house. We've also learned that in a battery, electricity always flows from negative to positive. Now, if you look on a battery, it's really easy to tell most of the time because it's actually labeled. On any battery, you can see on this end, it's got a little negative and this end, a little positive. On this kind of battery, a 9 volt, it's a little more difficult to tell, but you can tell, look, the tops of the battery are actually different. And if you flip it, oh, you can see that it's actually labeled. So we know that this is the negative terminal and this is the positive terminal. And if we turn it, we can see that as well. So we know that electricity always flows from negative to positive, or on this battery, from negative to positive. All right, grade 5, great work today on our short circuit lesson. I hope you learned something new. If you have any questions at all, please message me, Mr. Matt, or Miss Mavish on Edmodo. We are here to help you. And we will see you all soon on another episode of Simple Science.